Good day, amazing fans, and welcome to today's physics class. In today's physics class, we are going to look at this topic on the board, which is radioactivity. Based on the statistics I gathered from the previous post I made concerning the next topic to be treated, so the comments that came out for radioactivity happened to be the highest. So because of that, we are going to treat the topic. Now, this topic here is treated both in physics and as well as chemistry. Now, what is radioactivity? When you look at the word radioactivity, it is a natural phenomenon, okay? It's a natural phenomenon where unstable atomic nuclei lose energy by emitting radiation. Now, what does it really mean for the unstable nucleus to emit radiation? Now, the atomic structure, like we all know in chemistry, it's made up of three particles. All right, we look at the atomic structure. This is an atom, and it is made up of the electron revolving around the shell, and the inside is made up of the neutron and the proton. Why this atom becomes stable is because we have enough number of neutrons to hold these protons so that both of them can become compacted. And that is why this atom become stable. In most cases, where we have few neutrons or we have too much neutron, so this atom become unstable. So in that case, that atom is said to be, or the element that is holding that atom, the element that owns that atom becomes unstable in nature, and it's said to be radioactive. So now, what is radioactivity? As it is said, radioactivity is a spontaneous disintegration of an unstable nuclei. What does it mean? Unstable atomic nuclei. So why? Because the nucleus is so unstable. Now, the spontaneous disintegration of this unstable atomic nuclei, and as well as emitting particles. And these particles are electromagnetic radiation. So that is what radioactivity. This radioactivity was first discovered by Henry Becquerel. Henry Becquerel or something like this. Henry Becquerel was the first person to discover radioactivity in the year 1896. 1896 was the year that Henry Becquerel discovered that uranium compound placed on a photographic plate, which was covered by light filter paper. Now, what happened was that he observed that this photographic plate was meant to produce fog. Fog fell on this photographic plate. So when he discovered that a fog fell on this photographic plate, so Becquerel was of the opinion that this uranium compound that is placed on this photographic plate could be producing a sort of radiation which penetrated this light-proof paper, thereby making the fog to fall on that plate. So that was when he discovered that this uranium compound is producing radiation. And he then named that kind of element or the material which produces this radiation as radioactive element or radioactive material. So a few years later, Marie Curie and Harry Curie, they were husband and wife. Okay, so they two studied this phenomenon of radioactivity, and they also discovered that there are other elements which could emit particles, which could emit radiation. And one of those elements was thorium. We have thorium. and also a uranium ore, which is known as a pitch blender, could emit more radiation more than every other element. So this is how radioactivity came into what study. And now, for you to understand radioactivity better, number one key point that you must never forget, there has to be what? Unstable atomic nucleus. The nucleus, the atomic nucleus must be unstable. Yes, that is a key word. And also spontaneous what? Disintegration. What is the word spontaneous? What does it mean? Spontaneous simply means that what? No force, no input force, and it just start happening. It means what? It is a random process. It occurs on its own without somebody what imputing force on it. So we see the atom begin to shoot out. See the atom begin to produce what? Particles. All right. Why? Because the atom is unstable. It is not stable in nature. So a stable nucleus must have enough neutrons to hold the protons together. And like we know that the atomic structure, you must understand the atomic structure, okay? And the atomic particles, we have what? Electron, okay? Electron, the electron is negative charge, okay? Negatively charged. Then we have the proton. Proton is what? Positive what? Charge. And neutron is what? No charge. Okay? So neutron does not have charge. And that is why we said that what? The atom of an element is electrically neutral. Why? Because the number of protons here, which is positively charged, is equal to the number of what? Electron, which is negatively charged. Now, for us to understand radioactivity better, we must not forget some concepts. And the first concept we must consider is the atomic structure, which I have illustrated on the board right now. Then the next thing we are going to look at again is isotopes. Isotopes cannot be what? Forgotten. Isotopes, okay? We need to look at isotopes. All right. What is an isotope? Or what are isotopes? Remember, we are dealing with radioactivity. And for us to understand radioactivity better, we must look at what? Isotope. Isotopes. What is an isotope? Isotope is an atom of the same element. An atom now of the same element. Let's say, for example, carbon. Let's say carbon. Okay? Now, an atom of the same element having the same number of what? Protons. They have the same number of protons, but different number of neutrons. Now, that is why, for example, we have carbon 12 and carbon what? 14. So these are what? Isotopes. Both of them are isotopes. So we can have it in different elements. So it is from the relative abundance of this carbon, we have carbon 12 and carbon 14, that will determine the mass of what? Carbon. So as a result of radioactivity, so we can have this carbon 12 atom, it can undergo a radioactivity or radiation. Then it will produce another element. All right. So when we look at the types of emission, we will understand this better. Now that will now take us to the next topic, radioactive nuclei. Which nucleus is radioactive? Now, and why is this nucleus radioactive? A nucleus that is radioactive, it's what? Undergoing a random process. And remember, we said that what? Disintegration means what? Decay. When you disintegrate, it means what? It can decay, it can break down, it can split. So that is what it means. For a nucleus or the element to undergo radioactivity, it means the nucleus, the unstable nucleus is what? Splitting, is what? Breaking up. It's also what? Decaying. That's what it means. And with what? Emission of radiation, with a release of energy. So that is why I said earlier that radioactivity simply means that what? A phenomenon where an unstable atomic nucleus lose energy by emitting radiation. That's it. Now let us look at unstable nucleus now. Which nucleus is what? Radioactive. It is what? An unstable nucleus. And why is this nucleus unstable? Why? Because it's either we are having too much neutrons or too few neutrons. So that makes it what? Unstable. Now, radioactivity is of types, two types. First one is what? Natural radioactivity. This one, the atomic particle or the atom of this element undergoes radioactivity on its own without what somebody imputing force. That one is called natural radioactivity. For example, uranium compound. Uranium can split up. The atom can split up and produce another element entirely. So radioactivity is not a chemical process. So it's beyond chemical what? Reaction. Okay. Then the second type is what? The artificial. So this one is man-made. This one is done by man, by what? Bombarding the atom of an element. When you bombard it with a high energy, then you can make the atom to split or force up. All right. Now, let us go to types of emission. Emission. We have types of what? Emission. Types of emission. Number one, the first particle that you can observe is alpha particle. Alpha particle, and it is denoted by this alpha what? Particle. Alpha particle, or you call it alpha radiation. Then number two is what? Beta. That is beta. It is denoted as this. Then call it radiation. Okay. Then number three is what? Gamma. Gamma particle or gamma radiation. And gamma is denoted as this, something like this. Okay. Have listed the types of emissions. I will have the first one, alpha particle or alpha radiation. Now, in this alpha radiation or alpha particle, this is made up of what? Helium nuclei. So it's made up of a helium nuclei, that is He. And it is made up of two protons and two neutrons. And this helium nuclei and this helium atom is positively charged. It's positively charged. And secondly, we consider it in terms of ionizing power. The nature is helium. The nature of this is what? Helium atom, okay? Which is made up of what? Two neutrons and two what? Protons. And it is what? Positively charged. Now let us look at in terms of ionization. So this alpha particle has what? A high level of ionization. Highly what? Can easily be ionized. But it has what? A low penetrating power. So it can only penetrate just that filter paper, or it can be stopped by even ordinary wood, by ordinary paper. It can be stopped because it is very, very low in terms of what? Penetration. Now let us look at this beta radiation or beta radiation. So this one is made up of what? Fast moving electron or positron. Fast moving electron or positron. Okay, positron is another element, another atomic particle that is yet to be observed. But in higher level, we have other subatomic particles apart from the neutron, electron, and the proton. So here in this beta radiation, here is made up of what? Fast moving electrons or positrons. And here it could be either positive or negatively charged. That of what? Charge. So it is either positive or negative or charge. And it's made up of what? This, which is what? Electrons and positrons. Here, the last one here is what? An electromagnetic what? Radiation. Is what? Electromagnetic. So in terms of penetration, it has the highest penetration, and it cannot be ionized. So we can't ionize. So this cannot, the ionization is very low. And here, this one is moderately ionized, while this one here is highly ionized. So when you differentiate the three of them, so alpha particle has the highest ionizing power, but lowest penetrating what? Power. And also, here it is what? Positively charged. Now let's go to this beta. Beta here has what? Moderate ionizing power. It can moderately be ionized. And also, it cannot penetrate the way this one is, but it has what? High penetration than this alpha particle. Then gamma cannot be ionized at all. It can only be stopped by a very strong, in fact, is the highest. It can only be stopped by what? Concrete. It can penetrate everything possible. Okay, so this one, while this beta here can be stopped by aluminium, so the penetration is still okay. But compared to this has the highest. Now let us look at radioactive decay. Since we are still dealing with the unstable atomic nuclei. Now, the radioactive decay is the disintegration we are talking about, which is what? A random and spontaneous process whereby this unstable atomic nuclei loses energy. It loses energy by what? Emitting radiation. Now, we are going to be considering this based on the three types of particles emitted by what? A radioactive element. Now, the first one, if for example, we are having alpha emission, that is alpha emission. When you have alpha emission, this is what will happen, okay? If, for example, the element that is undergoing this radioactive decay is emitting alpha particle. For example, let's say uranium, atomic number is 238, atomic mass 238. Then we have 92. I think that's 92 for the mass. What will happen? It's going to reduce. Here will be reduced by 2, while the mass will be reduced by 4. So which means it's going to produce another element entirely. Let's say thorium. It can produce another element, which is thorium, okay? And thorium, the mass of thorium is 2. You take 4 away from here, 2, 3, 4, okay? Then take 2 away from here. That's 90. Then we are going to put plus He. Then the mass is 4 and this is 2. So if the element is undergoing alpha decay, this is called what? Alpha decay. All right. So the mass, the element, the original atom will lose what? 4 of the mass. All right. While the atomic number will be reduced by 2. That is for alpha decay. Now let us look at beta decay. Okay. Beta decay. What will happen is that what? The mass remains the same, but the atomic number will increase by 1. And we said that what? This beta, it is what? Either positive or negatively charged. Let's look at elements that is undergoing this now. Let's say, for example, let's say carbon 14. Let's say carbon 14, this carbon 14 undergoing a beta decay. What will happen? It will produce nitrogen. That is 14, okay? Another element, which is what? Having atomic number 7, because the atomic number will be increased. Then we have what? Is that beta? We have positive, then, or it could be minus. You can also put minus or plus V minus, okay? So this is beta decay. Now this is your gamma decay. So the mass is unchanged. We have, let's say, element A, then element X undergoing gamma decay or gamma radiation, it will still remain. Okay, that is Z, then plus the gamma. So this is what we call radioactive decay. So in our next video, we are going to be looking at half-life and some other aspects, some other subtopics on this radioactivity. I want you to stay updated. If you find this class very interesting, help us to share this post. Do well to like and comment. Bye.